So I'm going to go ahead and get that started. Okay, so we're going. So yeah, welcome everyone to this event on avoiding technical debt and going through kind of Morpse's journey. I'll let Jordan get into this more detail, but their tools that they've used in developing their Python packages and in GitHub to kind of reduce that burden and help collaboration among their teams. A couple of items before we start. We did People have probably seen launch the technical affinity group in NNIP on the community platform. I know some people have joined here on that, but for those who haven't, if you navigate to the affinity groups section on the platform, you can register for that. We've gotten a lot of excitement about it. I know a lot of people gave us a lot of feedback on things they were hoping for from this group. And one of them was to sort of brainstorm and get feedback on sessions like this that are a little more technical and more specific. So we definitely want to hear more from you. If you have ideas for future virtual sessions like this that are more technical oriented and maybe more specific than the broader group. Yeah, also thanks for the link in the chat, Leah, to register. We'd love to hear from you. And you should be hearing in the next few weeks, we'll be hosting another technical session like this from an NNIP alum. So you'll be hearing on that shortly. But with that, I will give it to Jordan. And just as a reminder, the first half of this session will be Jordan giving his presentation, and then the second half will be more interactive where people can share their experiences, ask Jordan questions, just have a general discussion. And at least for that part, if folks don't mind turning on their camera so that we can just have a bit more engagement, that would be great. But yeah, Jordan.
Cool. Let me get this pulled up. Oh, geez. All right. So, all right. Cool. Everyone see that all right?
Yep.
Let me move my thingy. Okay, so thanks everyone for being here. My name is Jordan Inskeep. I'm a data analyst at the Mid-Ohio Regional Planning Commission in Central Ohio. So this presentation is sort of the culmination of a lot of things that I've been working on here in Morpse, but also is deeply inspired by my master's degree. So I studied at The Ohio State University. I studied collaborative governance and social technical systems. So I studied urban spaces as social technical systems. So I approach I'm not a data scientist, I'm not a data engineer. And so don't judge me on my Python code, please. I'm specifically focused at understanding how we can use technical tools to develop collaboration, both within data teams, but also with the public and with everyone that's connected to these systems. So that's kind of the perspective that I take. Again, I'm a social scientist. I'm not coming from this from a super technical perspective, and you'll see that as we go through this presentation. So just to kind of go over what we're going to talk about today, first, I want to go through and talk about and define how I understand technical debt. And then we'll talk about some principles that I sort of understand as an important way of grappling with these ideas of technical debt and looking at our code base and looking at these tools we develop from this lens. And then lastly, I will hopefully spend most of our time talking about some of the tools that we've been developing here at Morpse. So to sort of level set us, the problem, so I understand the problem is emerging from this context, right? We're working on these modern data teams in various contexts, but really what we're doing is we're building these shared processes that we're using over time. We're using and reusing and developing and maintaining in little like changes in different contexts. Maybe that's a different neighborhood. We're running a process for a different neighborhood, a different geography, a different subject area. So we're using these processes, but we're adapting them time after time after time. And so this might look like, you have some source data and you have some Python code that pulls that into a CSV. And then maybe there's a Python class that you have or some function that produces a chart from that. So then maybe you do that again, but instead of producing the chart, you pull the data in, and then there's a manual process in Excel or something to produce a table for someone, you know, or there's a completely manual process, right? We could talk about this from the perspective of not even writing any code, right? It could just be whether an Excel workbook or whatever, every data team's going to have ways of doing things, and that's kind of what I'm talking about here, right? We're constantly doing these repeated acts over and over and over again, and that's fine and good, and it would hopefully work very well. But the problem is that throughout this all of these processes, there's people, right? There's like constantly people are touching these processes, this data. There's people who we get the data from, there's people writing code, there's maybe somebody working in Excel, somebody else writing code, and then there's our consumers of our data, right? Like whether that's a public servant or someone in a neighborhood, a community member, like throughout these whole processes, there's these people involved, right? We can't understand this purely from a technical perspective. And so what complicates our beautiful tools is that they're built by and used by people. And so all along the way, we have these complications that might come up that really come down to like, yes, we have data teams, but we want them to be diverse. We want them to represent our communities. So there's different perspectives involved. We have change, we have turnover, right? Like people moving from team to team, new team members, people leaving. There's various data interests, whether that's on our team in our organization or from the public. Maybe it was housing last year. This year, we're focused on air quality or et cetera. And yeah, so constantly we're sort of feeling the pressure of these very human elements. And so maybe like let's just talk about this for a second. Like what kind of complications when it comes to building your data processes, what kind of complications do you all experience in that? So I should have warned you. I'm going to ask you guys questions throughout this.
Well, I'll jump in. One issue that we've experienced is that folks in our leadership only care that the job get done. They don't necessarily care how, which is a good thing, mind you. But it's led to a let 1,000 flowers bloom kind of mentality, which means that everybody's using, until recently, everybody was using different tools. And that meant that, the person we had one person who was programming in R, and we had one person who was doing Python, and we had one person who was doing Stata, and then one person who was doing stuff by hand. And if the person who was maintaining the Stata code was on vacation,
Right.
we might not be able to do something because the other folks didn't, we didn't have a shared set of tools. And we've been working over time to try to standardize a little bit more so that we sort of pick a core technology. Obviously, there are still going to be cases where we're going to step outside of it, but we're trying to evolve toward using a more common set of tools so that we can all be, we can all help each other and cover when somebody's out and all that kind of stuff, which is why we decided to attend your talk today.
Cool. Yeah, for sure. Yeah, I mean, there's just even coming together as a team is and to build those shared processes is huge, and we'll get more into that as we talk through this.
For us, for a really long time, we built the data infrastructure from the ground up. And so now that we have like a cloud-based lake house in Databricks, I've kind of been really pressing the expectation that the work is done inside Databricks so that way it can be replicable and scalable over time. But one of the challenges initially was the architecture. So we had architecture built out for, the data sets that we get from stakeholders or partners, and not a problem. But where are we storing our scripts for certain projects or ad hoc requests, or if we have a table for a project, like where is that supposed to go? Because it's not really like we're not going to keep getting data on it. And so figuring out some of those things, we did over time, but we actually just completed like a huge technical debt sweep that took 2 months to basically go back and decide like, okay, this is the infrastructure we're going to move forward with. Here's where we're going to put our shape files. Here's where like projects need to go and how they're going to be named. And so kind of, you just can't really know what the problem's going to be until you're encountering the problem, right? So sometimes it's just hard to like predict like where to end up with issues. And but the infrastructure and architecture was one for us.
Yeah. It's interesting because it sounds like you two are sort of in very different technical environments, right? But maybe have similar social difficulties of this sort of working together, finding out which tools to use where, even though you might be working in these Databricks and have a fully fleshed out architecture. It's not like Moshe's working on just getting off the ground with building in processes and stuff. So I think that's cool. Yeah. And we can move on. I think for me, really this problem is like, no matter how sophisticated or how small or big or new, established the team is, like we can quickly accumulate this technical debt, right? And really that's going to prevent us from producing these durable outcomes. We might just have to keep redoing work over and over and over again. So just quickly, what are we talking about when we're talking about technical debt, right? Like, so IBM defines this as the future cost associated with relying on shortcuts or suboptimal decisions in the software development environment. Well, this can apply in a lot of ways, but really it's this future cost, right? We take shortcuts, we do something quick because it needs to get done. Somebody's saying, hey, we got to have this, we got to have this. So you write some code, you run it, and then someone comes back and they, well, we want that this way, but a little bit different. And now it's like, okay, can I reuse this script or do you have to rewrite it? There's an interesting paper that came out of a conference in 2016 looking at sort of formulating a theoretical foundation of technical debt. And they said that technical debt is a collection of design or implementation constructs that are expedient in the short term, but set up a technical context that can make future changes more costly or even impossible. So yes, what we're talking about here, and these definitions are specifically talking about software, software development, software environments, writing code, writing some of our own tools. I think this can apply in a lot of different ways. I think what is interesting about these definitions for me is like, okay, yes, suboptimal decisions. Well, who's making those decisions, right? Like in both of these definitions, what we're not getting at is that there's people involved here, right? Like it's not just about software. It's not just about code. It's about the people and the teams that are working on this. So for me, technical debt is not just a technical problem. It is most certainly, and I think for us, helpful to understand it as a social problem. So how do we understand technical debt as a social problem? So for me, technical debt occurs when we have these shared processes, these shared tools, without developing both a shared memory and a shared language. So by shared processes, I just mean these common repeated ways of doing things. Shared memory, I'm talking about a mutually produced and accessible historical record. Like how did we get to where we're at now? And then by shared language, I'm talking about what words, how do we refer to what we're doing, and how are we producing that language together so we're all on the same page? One quick note, some people will talk about culture to sort of talk about these things. They'll use the term culture. And I tend to avoid that language because I think culture sort of hides really what we're talking about, and it really makes it feel way more binary in how we talk about technical processes and sort of like social culture. And I see processes, memory, and language as all three of those having social and technical components. And we'll kind of get into that more as we talk about this. So here's sort of how I understand how we can build more collaborative data teams and while avoiding this sort of technical. So we have shared practices, these shared ways of doing things, and those are interrelated to the language that we use to talk about them and develop them and communicate about them, and the shared memory, the shared history of how we came to where we are, why it is we are doing the things we are doing. So we could sort of tie those to certain practices, right? There's obviously a lot of us are probably using reusable code, whether that's in Python or R and Stata, SQL. Those are sort of our shared practices. But we also have these other elements that kind of get involved in producing those things. So we have our metadata and our documentation. This is really how we build that language, how we figure out what it is we're talking about, like that we produce language through producing this documentation. And then version control, which I'll talk about some, is sort of recording this history. What are the changes over time to produce these practices and language? So I'm going really fast here, but I just want to get through to sort of talk more about what we're doing. So bear with me. If you have questions, feel free to stop and talk. But so yeah, shared practices. These are some ways we can think about what makes quality shared practices. That they're transferable, right? That they can go from team member to team member, and they aren't I've seamlessly-ish here because it's not always going to be perfect, right? People are going to have to kind of work through stuff, maybe read some documentation, but ultimately you can hand off a process to another person and they can get through it without too much effort. With that, also they're interoperable, that these practices work in different settings and sort of are modular, that they can be exchanged. So you might have one fetch script that pulls data in from some source, and you might use that for various different sources with just changing some configuration or something. And then I think also these need to be persistent, right? We're not constantly making ad hoc processes, but they're being used over time. So we can find them, they have the same name, they can be referred to in other processes, etc. So for me, this is really about the KISS principle, right? Keeping it stupid simple. Like, how do we build processes that are useful in many different situations and in many different combinations? Well, we build the smallest useful step possible. We break down the processes, we refactor, we think about the code, we talk about the code with other people. What is it? What are we really trying to do here? What elements do we really need here, etc. And for me, I can't do anything unless I redo it 3 times. So it's like I might build it in a context-specific space, then I'll refactor it to be super general, and then I'll rerun it again and have to make a bunch of changes in another context, and then maybe it's some useful code. So those are maybe some suggestions for thinking about this. So for shared memory, really what I'm talking about is like, how do we know how we got where we are? Is it even possible to know that, right? Like, is there any documentation? Is there any history of like how it is we got to where we are? I think this is really important to be transparent. So in order for our stakeholders to know, like, this is how we are producing the data that we're producing or the visualization that we're producing. And I think also it's important to know that memory or how we are where we how it is that we got where we are, that though the people who contributed to that process are identifiable, right? Like that we know who did it. We can actually talk to the person. It it's not just empty documentation or whatever, but people, we can go and talk to the person or reach out to the person and say, hey, why'd you do this? Or how did you get to this point? So yeah, for me, a couple of things that I try and do in my workflows. So like I'll try and write down what it is I'm going to do before I do it. Then I record how I actually did it, and then I do it, and then I record how it's different than how I thought I was going to do it. So you're sort of keeping record of not just how it was done, but the thought processes that you were going through while you were working on this. So really trying to make documentation and version control really like human, if that makes sense. Yeah, we can come back and talk about this if anyone's interested. Did I miss something? Yeah. And then, yeah, so lastly, shared language. I think one of the ways that I tend to think about this is the words that we use when we're making a commit or we're talking with our data team about a future tool we want to build, being really specific and using titles and descriptions that are both human and machine readable, right? These are human and technical systems. We need to make the useful for both parties. They need to be expandable. We don't know how things are going to change over time. We might have, and I have an example of this later, we might have a category of like workflows that we realize we need to expand. So we'll talk about that. So for the sake of time, I'm going to move on and talk through some of the stuff that we've been doing here at Morpsey. So really our framework, this is kind of how we've developed some of these tools. So we're working on developing a set of Python packages and modules to facilitate our work. That's a lot of what I'm doing right now is writing that code. And in order to build out that package, we also want to know in these workflows, building in that shared language and shared memory. So for the shared language, we're using Frictionless Framework, which is a really great lightweight metadata package that has Python implementation, and Jupyter Notebooks for our workflows. And then we're version controlling, we're building that shared memory through Git and GitHub repositories. Okay, so some examples. So the first example I want to show you all is a workflow. It's the Morpsey Pop Collect workflow. I don't know if anyone was on the presentation that Adam did last week or whatever, but he talked about our new Insights platform. This feeds that Insights platform. So this workflow really highlights how we build out modular processes. So each one of these is a GitHub repository that includes documentation, the output data, the metadata, etc. And they sort of feed each other in these chains. And so we can use these in multiple different workflows, and each process or repository is its own sort of environment in a sense. So let's see. Can you all see that? Can you see my GitHub?
Yes.
Yes.
Okay. apologies. I'm probably actually like, if you just got to look at that, you probably can tell like we are still working on developing ways of preventing technical debt. We have plenty of repositories that need work, but so this repository is our pop collect repository. So this is a typical repository for us. It has a notebook, an HTML export of that notebook with its outputs, and then some output data. This is like minimal, right? So here's the actual data. This is a data table that collects all of our population estimates and forecasts for all of our geographies of interest so that it can feed this dashboard. It has a schema file, which is it's a YAML for each field in the CSV with its type and a description, and a resource file with the file metadata. So this is the name, the description. It has a hash of the file for validating it. And so essentially each one of these repositories is one of those, and they feed each other in a chain. And so we can rerun, and I just had to do this for the new estimates that came out. We'll rerun the ones that need to be run and fed upwards into these higher level repositories. Another way that we've implemented developing metadata for these is through developing a Python module that uses the frictionless framework to import data from one package or one repository to another. So we wrote a little script here that will grab the output of one and load it to the other. And this, the nice thing about this is that, so for instance, this is the notebook in that repository that I just showed you all. So there's a bunch of stuff here. So this is one note, like build it for your future self. Like we have all of these different data sets that we have yet to implement into this, but we have this notation here and documentation to remind us about, what we're planning on doing. So the reason we wrote this morpc frictionless package is to essentially, behind this one line of code, to do a lot of different things. So we're not just importing the data from one workflow to the other, but what is this hung up on? I swear this worked a second ago. This is always how it goes.
5 demos, man.
I know, right? I shouldn't have. Here we go. Okay.
Every time.
I don't even need you to run. So as you can see here, so we have a logger that's implemented in all of our workflows. So it produces a log file for each one of these workflows. So again, here's one of the ways that we can know how we got to where we are, right? We have this log file. It will be archived in the repo, and it will tell us exactly what's happening. But what it shows us is here underneath this morpc frictionless load data, it's doing a number of things. It's loading the data from the frictionless resource file. So we're not actually importing the CSV, we're importing the resource. It automatically checks it against the schema, and it loads that data, converting all the missing values that can be designated in the schema to nans. And so that we implement this, instead of just loading a CSV, we're loading all of the previous metadata with that CSV into this continuous workflow, right? And it can sort of build on itself. Here it's, again, we're building this log over time to sort of make everything transparent, and we can understand where it is we got from where we are. So I can hand this off to somebody, they can go back and look and say, oh, okay, these are all of the processes that got us to this point. So this will, bring in the data, and not only will load our data, it'll validate the checksum, so it'll hash it to make sure it hasn't changed since we saved it. It validates it against the schema, converts the data types, and then also will convert any missing data to the value that we designate. And then it will also log all of that in our log file. And then lastly, and this is one of the things that I've been working on a lot recently, one thing that we do here is we use a lot of census data, and we're constantly pulling in different B tables at different geography different scales for different areas. And it might be tweaked over and over again. And we've had these scripts that we've been running, kind of like what you just saw, but we were producing a bunch of scripts with a bunch of different output files, and there was a lot of room for human error. So what I've been working on is this Python class, and this builds on a lot of the ideas that I've been showing you. So this is a notebook in our naming schema. It's an ACS. It's from ACS data. It's a population by race profile. So the last word here is a profile for us is something that produces a view or a visualization specific to a single use case. So I can show you. I definitely want to leave time for questions. So basically, this class hides a bunch of stuff. It hides how we define our scale and our scope. So like tract level for the county, or all MSAs in the nation, or we can define that in these parameters. And then it will pull in that data. And again, it's going to log everything. It's going to use our frictionless package to build everything. Oh, sorry. I already did this. So here's the output. I downloaded 3 different years for B02001 for a region. The sets our economic development region, and these are the 3 resources. And so again, we have a schema, we have a resource file, and all of this data is automatically named based on our naming conventions, et cetera, et cetera. So there's a lot going on behind the scenes here, but the point that I'm trying to make is the reason it works for us is because we're talking about what language we're using when we're building these things. What do we mean by scale? What do we mean by scope? And we're building a history so that we can go back and we can look like, okay, he used the API class to bring in this data, and et cetera, et cetera. It saves us a lot of time by having to rename things, rewrite things, et cetera. So that leaves us about 15 minutes for questions. I'm happy to talk through more of the technical stuff here, depending on what you guys are interested in or whatever. Let me go back. Sorry to rush through the end of that. Okay, so yeah, let me hear from you all. What do you guys think of this stuff?
And Jordan, do you want to take the slides down so folks can see each other, unless they need you to refer back?
I think it's really interesting. I think I'm really impressed with how far you guys have gotten with the implementation of this and parameterizing and normalizing it. I mean, specifically census, because there's so many layers to it and a lot of ways you could do it. I would just go and say I think this is a great example that I can take back to my team to show them how far and the extent to which we can go. I think that when we use this type of model, so we do parameterize a lot of things, like we have a parcel identifier function that kind of normalizes the structure because it's different depending on which office we're getting it from. And it took us a really long time to get that function right. But, because it's parameterized, every change we made would then be automatically applied to all the other uses of it, for different data sets. So using that structure, we kind of have common utilities that we've built out. And that's been really, really, really helpful. I just think there's like another level that we could take it. I'm thinking specifically about like census, because I just tried to rerun the 2024 and I got an error about like geographies not being ready. And I'm like, nope, that data is definitely up there. So there's something going on with the code, and now I have to go troubleshoot and figure out what's going on. But if it were set up this way, it would probably be a lot easier for me to just run it.
Yeah, I think really it's been really helpful for us to focus on transparency, not just for our consumers' sake, but for our sake. We can really understand, okay, like what are we doing here? And for me, even like debugging, I can like it's just I don't know how people don't have this level of history to look back on. And yeah, so it's a good point.
It makes it really hard. My comment was more about like we have metadata about data sets because I work with like technical and non-technical people. And so we kind of need a shared location to explain what the scope is of the data set, what's the history, where's it coming from, where is it helpful to use it, and then also like where's the code, and keeping that updated itself has been really, really hard for us. Like there's a bunch of stuff that's outdated that we need to go back and change and fix, and it's like ideally you're documenting as code, but for our non-technical folks, they're not going to be able to do that. So like, how do you kind of balance between the two? And that's something I'm still definitely trying to figure out.
Yeah.
I like this description of technical debt because I've read about it before, but in language that's used for other industries. And so hearing it in this language really has me understanding how it applies to our current work and where we can improve our own efficiencies. So for example, we do have multiple people who might touch code and then make their own individual changes to it. And the way that we're keeping track of it is honestly just within the code itself, keeping notes. But we have discussed using GitHub for that purpose because, you can keep track of it in there. But something that we've run into with that is making the decision of like, okay, does everyone get their own GitHub account? And then we just give permission so that they can alter that code. Or because what we've been doing is like, one of us will just log in to the main GitHub account, but then you got to go through two-factor authentication. So you got to make sure your coworker is ready and has their phone so that they can make sure that you can get logged in, and then you can go alter it and keep track of what it is you did and why. And so right now it's just us feeling out what's best for us and what will be easiest. So that was really helpful. And then you had another point that I really liked. Come back to me.
Yeah, this is I think it's really impressive what you've done over there so far with you and your team. And I think we've talked about some of the things that you've shown, but we've not really come close to implementing anything close to what you guys have managed to show there with all this documentation around packages and creating those. And I think that requires a shared understanding and commitment from all of the people that are working with data on your team to be like, okay, like we're going to use these packages, we're going to commit to following these documentation methods and procedures, and it just takes time, frankly, especially to generate metadata or data set specific documentation. Something that we face a lot is like trying to almost garner there's like immediate needs you have to service certain community members, and then there's needs like this, and it's hard to try to properly apportion the right amounts of times and efforts to getting something done quickly and, trying to think about not making technical debt.
Right. Yeah, I mean I'm not gonna lie, I produce a lot of technical debt. But I, but I think like so maybe I'm not the best to talk about this uh topic, but I think I think the thing for me and is that understanding that you're always going to be making changes. Like in not expecting our code base to get to a point where it's, I think for what we're doing, I don't ever expect us to, quit making changes. I don't know if that should be our goal, but for me, the goal is for us to produce useful things, that are useful for us, and not just in the moment, but over time, developing a toolkit that we can share among our team. Um, there's things that I've made that I don't think Adam uses, and there's things that Adam uses that I don't use, but those all can be housed and have a common language so that if I did want to use them, I can actually figure out what it is that he's doing, and he can figure out what I'm doing. Yeah. Um, Austin, you had your hand up. Go ahead.
Yeah, thank you. No, thanks for this. I think, my organization is kind of like coming in with people using three different kind of languages, and in the middle of going, all right, we created this integrated data system in one language that now only one person really knows how to use.
Stats.
In SAS, and like we want to take it to something else that's non-proprietary, and I think as part of this function is also doing some of the GitHub, like getting people to onboard onto GitHub. Could you tell me, like, I don't know, some of your key takeaways from, like, or some of the barriers that like we're experiencing getting people onboarded with this sort of stuff, and like uh, and maybe changing some like mentalities around how to collaborate and work, because I think there's just like a different set of collaborative tools available to folks now than there was even 5 years ago, and that a lot of it can be really open sourced as well. So how was that like navigated, and what kind of key takeaways were like, I don't know, even